This is the code I posted under the code section for today. You can either open this file in RStudio or you can just copy and paste it into a new R script, which is I'll do that. I'll just Control C, copy it. And remember to always be in RStudio, not R. To open a new script, File, New File, R script. And remember, you always want to be writing in this R script zone in the top left. Now just paste the code, and everything I hashed out is green. It's notes. So if you run it, like Control Enter this, it doesn't do anything. R knows that everything that follows that hash symbol is notes, and it won't run as code. Let's look at sampling in R. The command is sample. And notice how when I typed it, this yellow box pops up and shows me the parameters for the code. I want to sample from X. Then the next command I give it is the size of the sample that I want. Replace is set to false by default. So if I want to sample without replacement, which is usually the case, I don't have to put anything in. I would write replace equals true if I wanted to sample with replacement. And this last parameter, prob, is something we don't use in this class. It assigns probabilities to the elements of X. A simple random sample uses what's called a uniform distribution, where the probability of selecting an element is the same for every element. So if you have 10 elements, the probability of selecting any of the 10 will be 1/10. The prob command will allow you to assign different probabilities to each object. So maybe X consists of like, let's say a lemon, an orange, and a cherry. And you want to sample from that, from a lemon, orange, and cherry 10 times. So you're going to have to sample with replacement because you want 10 items and there are only 3 to choose from. We'll set replace equals true. And I maybe want the probability of a lemon to be 1/2, a cherry to be an orange to be 1/3, and a cherry to be 1/6. And these numbers will have to add up to 1 because it's probability. And I just hit enter, Control Enter. And you see down here, it gave me a sample of oranges and cherries and lemons. And I can run this code over and over, and it should give me something different every time because it's taking random samples. You can enter sample into this help tab in the lower right, and it will tell you more about it. Recall that the code seek161 will give you the numbers from 1 to 6. So if we let that be the X, we can simulate rolling a single die like this. Sample from the numbers 1 through 6 one time. We can also use this shorter notation for the same thing. In both instances, I'm taking a sample of size 1 from the numbers 1 through 6. Because I'm only taking a sample of 1, I don't care about replacement. But if I add 2 dice, I can do it like this. or like this. What I'm doing here is telling it to take a sample of size 2 from the numbers 1 through 6 and add them up with this sum command. But notice I need replace equals true for this. Otherwise, I couldn't roll the same number twice. If I roll the number 6, the second roll would only sample from the numbers 1 through 5. Now, if I want the sum of 1,000 dice, then the second version is a lot easier to use. And you can see here that R accepts T for true and F for false, so you don't have to write them out all the way. But let's run this a few times. And you can see the results down in the console here. It's bouncing around because we're drawing different numbers every time, but they seem to be hovering around the same number. Now I'll show you how I did the sampling on the farm. Setting the seed is there so that I can replicate the results. What it does is gives me the same random numbers every time. It's not really necessary for the code, but hopefully you'll be getting the same thing I get. Now first I make a vector of cow weights by randomly drawing 12 numbers from a population with mean 1,500. You'll be seeing this R norm code in week 4, so don't worry about it now. All you need to see is these first numbers. Notice that I'm drawing 12 cows, 48 sheep, and 240 chickens. So I'm simulating the farm from the lecture. Let me run this code. If you look at the top right, you can see that these are all vectors of numbers. They're collections of numbers. I can use the C command to put them all together into one vector, which I'll call farm. And if you look at the top right up here, you see that farm is now a collection of 300 weights. If I take the mean of farm, the average weight of an animal on the farm is 93.66. The average weight of the cows is 1,501 pounds. And the first 12 animals are cows, and you can see how I'm referring to them with this bracket notation. I'm saying take the mean of the first 12 elements of farm, and those are the cows. So if I run this code, I get the same thing. A simple random sample without replacement would go like this. We sample from farm, size is 25, and I don't need the replace equals false because that's the default, but I just put it in there so you can see what I'm doing. Remember, the mean weight of animals on the farm was 93.66. So if I take a sample and take the mean of that sample, what do I get? 93.69. That's pretty good. That's almost dead on. That was a good sample. But let's run the code again. That one's not so good. That one's way off. That's only 19 pounds. And again. You can see that when I take a simple random sample and take the mean, it bounces all over the place. Let's look at the stratified sample. The first 12 animals are cows. The next 48 are sheep. And then there's 240 chickens. So you can see I'm sampling 1 cow out of 12. I'm sampling 4 sheep out of 48 and 20 chickens out of 240. And I enclose everything in this C to just put them all together into one vector. And I'll store that as strat S and take the mean of strat S. Now we're aiming for 93.66, and you can see it's not perfect, but if I run it a few times, it doesn't bounce nearly as far as the simple random sample did. The stratified sample gives you an estimate that has less variability.